All right, so last time when I was looking at this board, we had two problems. We had the controllers were not acting well. They were not smooth in delicate adjustments. And also we had no audio. So I printed out the one sheet that has both of those on it. We got an LM380 equivalent for the audio amp output. So I will check to see if that is getting power and to check to see if signal's getting there. If it isn't, that chip's bad. Also, we have a potentiometer that may not be letting the signal pass, so I'll check that out. This is not really focusing well. Okay, so the potentiometer is right there. So it looks like it's a 10K. Let's see. Yeah, so a 10K potentiometer. It may be bad, not letting the signal through. I'll clean it and see if that helps. That's for the audio side. Now the controllers are here. All right, so you got a controller input here, goes through a pin to come to the, this is a 5K by the way, 5K potentiometer, what I installed in the controllers on the last video. That's coming in, and here's the other one. So it's coming into a, let's see, what is that? 555 timer. And there's the capacitor there. That's a 1 microfarad capacitor that I think is probably opened. It's probably no capacitance, or it's weak capacitance. That's what I suspect is causing the problems. So I will lift one end of that capacitor and check it and see if it's good or bad, and that should tell me if that's what the problem is or not. This capacitor here is going to be a ceramic capacitor. That probably isn't going to be a problem. I think it's this one right here. All right, well, let me get the scope out and start probing around. As I'm playing the game to figure out problems, I've discovered that this line here, see how it's got that bright spot right there, and also how the ball kind of goes into the wall, not bouncing perfectly. See that? That line there is misplaced, so there's a logic problem. This one looks pretty good. In 2-player, this bottom line is thin. It's half the size it should be 2, and that's probably related to the same problem. So that's an additional problem that's going to need to be fixed. So let me, I don't know if I have the schematic for that. I probably don't. I'll have to go in and print it. So I'll save that problem for last, or for later. And I'm going to focus on, let me focus on the, let me try replacing those capacitors in the paddle circuits to see if that doesn't improve them. Okay, the schematics that I have don't show this capacitor here going from pin 5 to ground on the 555. I'm looking at a different board here. This is also an Atari Breakout. It's labeled an Atari Breakout. It must be a newer revision, because it does have the capacitor on pin 5 going to ground here. So this must have been an afterthought. Somebody added that, or revision 1.5 or something. This might be revision 2. Well, actually, this is a revision 1 board, I guess what I'm saying, and they added that mid-production or something. Then they corrected it on the layout of the board and added it there. So this apparently is correct. I'm not going to touch this. This is the capacitor I want to replace. I'm going to replace it first. If it doesn't improve completely, then I might replace this one, because I don't understand this one. You look at the schematic here. Pin 5 is here. They have a 0.01, if it'll focus. They've got a 0.01 capacitor that does not have a 1 microfarad capacitor. So I need to see if there's a 0.01 and a 1 microfarad, or if they just decided to go with a 1 microfarad. All right, so anyway, I'm going to be, like I said, I'm going to replace the one that's in the schematic. I'm going to replace it, and then I'll consider that one. Okay, so I lifted one end of that capacitor, and then I soldered in a new 1 microfarad capacitor. And here's what happens now. It's horrible. It's even worse. The old capacitor is checking out. It's over 1.5 microfarads, and the new one's checking out at about 1.1 microfarads. So this one's more accurate, but this one's giving a little bit better result. So I need to figure out what is actually wrong. So it's not the capacitor, apparently. Something else is going on, causing it to jump around. I hope it's not the potentiometers, because they're brand new. I would hope that's not it. All right, I'll keep digging. All right, so the paddle problems have been resolved. It's beautiful all the way across now. That's player 1. That's player 1. Now let me show player 2. Player 2. It's beautiful all the way across, not jittery. Smooth as silk all the way. All right, so the problem was I had miswired the controllers when I put the potentiometers in. I connected ground to the other side. That's how the Atari 2600 wired them. This does not. If you look at the schematics, and I really never even paid attention to it. If you look at the schematics, you'll see that the one side of the potentiometer is floating and the other is tied to 5 volts, but I had this grounded. I was thinking this needed to be a voltage divider, and it's not. It's just a variable resistor. All right, so that solved the controller problems. Now I'm going to start focusing on the audio. I've already probed around some, and we've got 2 signals coming in. We've got a vertical ball hit. I guess that's what VB stands for. We'll just call it hit sound. VB hit sound, okay? So that we're getting a signal there, and we're getting a signal for brick sound, okay? So those signals are 5 volt levels coming out of these two chips. Well, yes, out of those 2 chips, full 5 level. So now it's coming in. I haven't checked this because I haven't got a free game, but regardless, I should be getting something that comes through the potentiometer. When it gets past the potentiometer, the signal's very weak. It's like 1/10 of a volt or 1/2 a volt or something. It's pretty small, but you can see it. So is this chip bad? Is that enough signal? I mean, this is a voltage divider here, right? So we should see a very small signal here, like less than a volt for sure. I mean, it really depends on the setting of the potentiometer, but yes, we should be able to see 1/2 a volt. And we've got a capacitor here that's a 0.1 microfarad. I need to see if that's bad, because if that's a coupler, right? If that signal is weak here and that's bad, then there will be no signal here for this thing to amplify. I need to do some tests on this LM380 and see if it's bad or not. I guess I'm suspecting this is bad though. At this point, let me see if I can figure out how to test that. I've looked at this with the scope, and I can get it to focus. There we go. We've got like 5 volts on pin 14. I don't know if that's correct or not, but it's 5 volts. If it's supposed to be higher than that, then maybe that's the problem. But the other boards that I've tested work fine on 5 volts. But maybe, okay, so this schematic says LM380, but the actual chip here is an ULN2280B. And from what I can tell online, these are identical chips. So normally when you have an amp and you put your finger on the legs underneath the board on the solder side, you'll get a hum, usually. We're not getting that here. So I'm thinking this chip is dead. It's probably bad. Let me remove it and put a socket there and then see if I can dig up one. But if I don't, then I'll have to order one or try to rig something. All right, so let me see what I can do. To move on to the next board. Got some corrosion, very bad corrosion here. That might be affecting stuff, especially around this clock circuit. It had an LM380 that was socketed, so I installed a socket in the other board and plugged this in, and I didn't get any audio there. I'm wondering about that voltage that supplies the amp, that unregulated voltage. I wonder what that is supposed to be. If it's not supposed to be 5 volts, then that may be the problem. I'm going to look at the schematics when I go inside later, but for now I'm still just looking at these boards. This board is doing that. It's giving me quadruple image. And if I touch this crystal, it goes away. So there's corrosion here. I'm gonna take this crystal out and clean that area up and replace it with a new one if I can find one, and see if I can get this stable, because right now it's not stable. If I grab it and pull it, I can get it to come up, but it's not right. Also, there's going to be a counter or something bad. But I need to do something about this corrosion that's down here. It looks pretty bad. All right, I guess let me remove the crystal and I mean, yeah, I've got to do something because it's out of whack here. I'll remove that chip, the crystal, and then I'll see if I can see any trace damage, I guess. This one may be put on the back burner. It looks pretty bad. All right, so yeah, this is in bad shape. Traces for the crystal are lifting. There's corrosion, rust, whatever, all over the damn place. These jumper wires, that looks like my work. I don't remember doing it, but that looks like my work. So this board has been looked at before. I don't know if I even want to mess with this. Well, the crystal's rusty. I can clean it up, clean up the legs and get a better connection, and that should stabilize the clock at least. I'll do that much, see what it does. The board is in horrible shape. I took some sandpaper and I sanded the other side. I sanded this side, cleaned up a bunch of stuff. When you have that kind of corrosion and it crosses between two traces, it makes an ohmic connection, so it can affect logic, and that's what I think is going on with that. It's probably a counter where two of the inputs are kind of ohmically connected. I was able to get the clock to stabilize, but the joints in the clock circuit are in just horrible shape. They won't take any solder. So what's going to have to be done is remove all the chips in this section, sand it down, clean up the area. But before I do that, I think this board needs to go through a bath. What's that stuff called? Evergreen or something. I've got some. It's in a spray bottle. I'll clean this up with that. But half the board's in horrible shape, and the other half is not bad. So this side needs work. Probably the first couple rows need to be worked on heavily, and then this side's pretty clean. So I'm not sure what the hell. This must have been just stored poorly or something. Or maybe with boards that had batteries that were leaking, and that might be battery acid damage. I just don't know. But when I sanded all this, I also could have damaged the traces if they were weakened by the corrosion. I could have caused some opens, which I can fix once I get the schematics and start tracing the stuff. But I think I'm going to put this one on the back burner. The reason I was interested in it is because it had the LM380 socketed, and so I could put it on the other board, and it didn't work. So I still don't know if the voltage is wrong to this, or if these chips are bad or what, but we'll figure it out eventually. All right, so this is the third of 4 boards that I have that I thought was working, but it ain't. That's what it looks like. It's got problems. It won't coin up. I think it coins up, actually. It just doesn't serve the ball. And the controls are out of whack. It doesn't go the full distance. Oh, yeah, it does. Huh. Earlier it didn't. All right, so yeah, this one, maybe I didn't work on these at all. I think that one that was all eaten up I did. I thought all these were working, actually. All right, well, let me plug in the 4th one and see what it looks like. I was mistaken. I only have 3 boards. The 4th board that I thought was a breakout is actually a Super Crash that Atari made. So that'll be a future project. I had totally forgotten I had that. So I'm going to continue on the first one that I was looking at. I went ahead and put the weird ULN 2280 chip back in the socket here. I am going to research the power requirements for this, what that 10 volts unregulated, not 10 volts, what the voltage unregulated is supposed to be. I'm suspecting it's supposed to be 10 volts, and it's only getting 5, so that may be why this isn't working. I would think you'd get something, a hum or something, but maybe not, who knows. So that's my homework assignment, and then I will continue on this at a later date. Thanks for watching. I said Super Crash, it's Crash and Score. Super Crash. I don't know where I came up with that. It's a Crash and Score board. So I don't think I've ever plugged this in. Ooh, look at that. That looks bad. Somebody didn't have a power resistor, so they made a makeshift one there. Well, all that's coming off for sure. This will be powered with a switching power supply, so this resistor will not be needed. Now, if you're going to put it in an original cabinet, that would need to be replaced, but not the way I'm going to be testing and supplying the power. Just 5 volts from a switcher. All right, now that's the end. Thanks for watching.